Jam, let's jam. Okay, talk to me here. Raise your hand if you think you've solved it, or you've solved it. Or, Mr. G, what are you talking about? That's the other part. Okay, cool. Let's start it here. So I got cosine.
So is this a continuation of 5.3?
This is, oh, sorry, here. 5.4. How about half angle Let me turn in my notes as well here. The half angle formula, actually we should say formulas. Boom. Which one we got started with first here? 2 cosine. -1, perfecto. So we keep on developing this this trig stuff. So chapter 5 is all about developing all the different interrelationships between all the different trig functions here. We started off 5.1 with all the basic ones. We learned all the way from chapter 2, and then we added on to, oh, the addition formulas, right? The subtraction formulas, that was cool. Raise your hand up if that was cool. Okay. Then we did the double angle formulas, which we can actually even do the triple angle formulas, the quadruple angle formulas. That's cool too. That's just an extension. But then we want to go backwards. So how do we find half of an angle? That's what we want. So we want to be able to find, oh, half of 15 degrees. Half of 15 degrees, 7.5, right? 7.5. That would be cool. Because with the sum of different formulas, you can only subtract them in order to get 15, but you can't take half of that. And so then you keep on going. Half of 45. 22.5, is that right? And so for the Greeks without a calculator, that they can't just press sine of, right, 48.62 degrees and click enter. That's no fun. For them, they had to do it manually. And this is sort of their process of trying to get that. Through this process, they find all these different relationships. Guys, question?
I just said that must have sucked.
No TI calculator? How do you survive? Okay, so first things first, let's go for it. We're going to solve for this guy. I'm thinking add 1 to both sides. Will that work? At least we have this now. And let me just check one thing out real quickly here. All right, divide by 2. This is just nice algebra here. Boom, boom. So I got cosine of 2a plus 1 over 2 is equal to cosine squared a. That's weird. So I actually have to solve, still want to solve for cosine. So I'm going to take a square root. And we know from algebra class, whenever we take a square root of something, we always have to put a little plus and minus into it. And these guys are going to cancel. Are we good? So let me write it the way the book writes it. The book writes it as cosine of a is equal to plus or minus. And what they do, they put the 1 in front, which doesn't really matter that much, but they want to have the 1 in front. And voila, this is so cool, right? Because if you double something, if you reverse the flow, you can half it. That's what we have here. Okay, one little extra piece here. 2 things actually. First thing is, notice it's only an angle. It's not a half an angle. So let's convert this into half an angle. And all we're going to do is we're going to cut all the angles in half. That's what we're going to do. So instead of this being a, we make this into be an a over 2 plus equal to. Guys, this is so cool. We just advanced trigonometry once again. Half of 2a. It'll just be an a. Are we good? So that's the way the book writes it right here. If you want to write it in as a formula. Okay, now we're kind of stuck here. This whole concept of the plus and minus. Notice it's the formula. We get to choose which one we want. Do we want the plus or the minus? So that's weird. How is it that we actually have to choose? Adrian? Go ahead.
Probably had it.
Say again, say again.
No, I'm just guessing how to do it for quadrant.
Perfecto. You guys are super bright. Amaya? Same thing?
Yeah.
Yeah, you wait until I say if he's right, and then you say yes, absolutely.
Yes, exactly.
There you go. That's the flow, making sure.
She obviously has a record of like benefiting off of other people's answers.
Yes,
That's something that she
absolutely.
would do,
Yeah,
definitely.
exactly. Okay, absolutely. Which quadrant you're in? So let's see. Let's talk about this here then. So if I'm an angle in quadrant 1, let's say I'm in theta. This is the little concept we got to sort of understand. If I take half that angle, which quadrant am I still going to be in? So let's think about some values here. So if I'm at 45 degrees, half of that's 22 and a half. I'm going to go from quadrant 1 back to quadrant 1. Okay. The highest angle I can make in quadrant 1 without going over is like 89 degrees. Half of 89? 44 and a half, yeah? Okay, so real quick here, if this makes sense, if you start off in quadrant 1, you still end up in quadrant 1. Are we good? And we'll put this together in a little quick table in just a second here. Okay, so now let's go on to the next one. If I am in quadrant 2, yeah, we go like this here. If I'm here now, here's theta, here's my little dot. I take half of that angle. So let's see, maybe the middle of it, 135. If I'm angle 135, half of 135. I mean, you guys do mental math here today. 62, so 60, something like that, somewhere in that range. 67 and a half, maybe? Okay. In all intents and purposes, we still go from quadrant 2 back into quadrant 1, right? In fact, let's go the highest angle we can make about. So 179, 178, somewhere in that range. You take 178, divide by half, or divide by 2, sorry.
So it'll always go back to quadrant 1 because if you split it in half.
Awesome, and we're getting it. Yeah, quadrant 2, the final answer will go back to quadrant 1. We're good? Because you're just taking half. All right, so let's do this for the next one here. So boom, drop it into quadrant 3. Middle of the road, 225, half of 225. $112 and a half?
Yeah.
Okay. So that means quadrant 3 gets back into quadrant 2. It's like somewhere over here. So let's see, let's go with the highest value here. So that's 270, so 268. $134. Actually, that's so weird because we're not even halfway through quadrant 2 yet, huh? Because we go back to 134. Interesting. So starting off in quadrant 3 gets us back into quadrant 2. So let's go over here now. What will this be? Half of this one would be what, 315, I think? 45 degrees away from 360. Yeah. 315 cut in half. About, yeah, did that work? Exactly, maybe. Yeah, so that just totally makes sense because if you're at 360, right? Cutting in half will get you back to 180, right? You're cutting half a circle. Okay, that's cool. So quadrant 4 gets you back into quadrant 2. Awesome. Okay, I'm gonna make my little table of it. If theta starts off here, then theta divided by 2, or you could say A divided by 2, whichever, doesn't matter. Because if it starts off in quadrant 1, it ends in quadrant 1. Starts off in quadrant 2, it still ends in quadrant 1. Quadrant 3 now ends in quadrant 2, and quadrant 4 still back to quadrant 2 when we take half angles of stuff. Okay, we're good there. Still developing. with GM. So that is, we got the cosine. Nice. So a few people still writing things down, so I'll wait a little bit. Cool. Let's do the next formula. So this step is going to stay the same. That's going to be forever for us. Anytime we do that with cosine, sine, or tangent, it doesn't matter. But your job, if you choose to accept it, let's go with double angle formula for, go back real quick here. Cosine of A. Let's do the next one. Cosine of A is 1 minus 2 sine. Yeah, we're good. Squared A, 2A. Sorry guys, real quick here. I'll get there. This is cosine of 2A, that's A. There we go. Getting confused between doubles and halves here. All yours. And mark it, set, go. Can you solve this guy for sine A? Just like we did cosine A. So we're trying to solve for this guy. And then you can look to see how we solve the first one if you want to as a reference. It's going to be very similar, but again, just developing these half angle formulas. All right, and hopefully we are close to getting done here. I got this right here. 2A minus 1 is equal to a negative 2 sine squared A. Divide by negative 2. And that's the fun part. Divided by negative 2, it's just going to switch the signs on top, right? If we bring it up to the top. So in this case, it would be a negative cosine 2A plus 1 over 2. Boom. And then, let's see, so that's the way we move it around. So let's move this around so it looks at least nicer. So I got this right here. Is nicer a word? I don't know. Okay. And take square root of both sides. Plus or minus on this side here. Let's move this guy to the other side here as well. So sine of A is equal to plus or minus the square root of 1 minus cosine 2A over 2. And we're almost done. One last final thing is cut the angle in half. And voila, this is so awesome. We have developed another half angle formula. And in mathematics, and for mathematicians, you know, what they do is they kind of latch onto something and they're like, hey, what if, you know, they develop a whole new world of what ifs. And then eventually when we do get to applications, we don't use the other ones, we're good. So there is a formula we can probably do tangent, but there's a formula for tangent. There's a formula for cosecant, secant, and cotangent, right? But then the question is, do we want to go that far? Because once we have sine and cosine, can't we just do the ratios and be done, right? Because that's gonna,
Is the bottom one supposed to be 1 minus cosine A over here?
yes, Gren, it's right there. Thank you. Oh wait, we cut it in half, that's perfect. Okay, and let me just jump to this here. Okay, so let's jam with these guys here. First things first. Yeah, let's go with, let me do example 1 right here. Doing find sine of 15 degrees. Find the exact value of sine of 15 degrees. Let's see, what's the other stuff here? This morning I sent out the challenge problems for chapter 5. There are 3 of them. So Canon students, you don't need to do any of them unless you want it for extra credit. Honor students, you have to do at least 1 because there's only 3 there. They're kind of challenging. They're kind of a fun little challenge here. Maybe we'll go over them on Monday just to get you the beginning of it. They are due the night before the exam. And so let's see, I don't think we'll get through 4 today completely. So we'll probably finish up 4-5 Monday, 5-5 Wednesday-ish. So I'm thinking test either next Friday or that following Monday. Kind of
It would
hanging.
probably be better to do it on Monday.
That's what I'm thinking too. Give you guys an extra weekend there, and then.
Yeah.
Yeah, let's do that. So it'll be the following Monday. All right, let's go over it. So sine of 15 degrees. Isn't that the same thing as sine of 30 degrees divided by 2? So I'm kind of setting up this little piece right here. There's sine of the 30 becomes my A value. The 2 becomes part of my formula. And now I can do that. The only question I have is which sign should I use? Plus or minus? Quadrant 1, that would be a positive value. And we have 1 minus, ooh, this would be cosine of 30 degrees divided by 2. All right, everybody good there? A little bit of algebra here involved. So you just got to go, keep on going with the algebra. 1 minus cosine 30 degrees, anyone? Have to tell. It's like I could tell like this, like Grant, it's in the back side of the textbook.
I know.
Is it 1/2?
1/2? Don't think
Square root
so.
3 over 2.
Grant square 3 over 2 from memory?
It's a 50/50. Yeah.
Uh-huh.
I chose, I would like one.
Yeah, okay, perfect.
You were, yeah.
I just need to know that is what I was good for, but I think 1/2 is bigger than square root 3 over 2 all the time when it's not.
So let's go with it here. So this one, again, lots of simplification, sort of pre-algebra to do. I guess I need common denominators for the top. So that 1 changes into a 2 over 2, I guess. Yeah, that's right. I got that on my hands now. Then I'm going to make that into a single term. So then I have 2 minus root 3 over 2 over 2. Oh boy. So then, oh, you know what I can do? I can change it into a multiplication now. So check this out. I'm going to go like this. I'm going to go, that keeps the same, but that little 2 over 1 now becomes a 1 times 2, or 1/2. So how do I like the answers? All right, in this case, how about 2 minus root 3 over 4? And how about a square root of 2 minus root 3? Oh, sorry. This should stay on top now. All that divided by 2. Whoa, does that look like a funky answer? I have a square root that's inside another square root. And that is the exact value of sine of 15 degrees.
Wait, where?
It's
What's the right?
The direction. Yeah.
Like,
What's-
like the program.
this guy right over here.
Wait, so
Talk to me here. Sorry, Matthias, first, go. So I went from here to here to here. Then I changed it to a multiplication of 1/2 instead of dividing by 2. And then this guy's became 4 inside the square root.
And so then we just.
And then I took out the 4 to give you a 2 on the bottom.
you can't really see your pointer when you're.
Oh, gotcha. That's no fun. Ooh, laser pointer. Doo, 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 doo.
Yeah.
So this one became one single term. We got this division by 2 still. So this stays the same. I brought it over here. And I made the 2 over 1 to be a multiplier of 1/2. So instead of being dividing, it was a multiplication by 1/2. 2 times 2 became a 4. So that became a perfect square of 2. So then this little square root symbol only went to the top this time. And then the square root of 4 became just a regular 2. We're good. So for square roots, the simplification of square roots, you can't have a fraction inside the square root. That's one thing. Second thing is you can't have a square root on the bottom. So we have fulfilled both simplification rules of square roots. Even though there's one inside another one, that's still okay. There's no fractions inside the square root, so we're good. Okay, good there. Got time for maybe one more. Okay, let's do that here. Exercise 2. Cosine. Well, we can do 3 more. Cosine of 105 degrees. All yours there. See if you go beginning to end.
This is a team effort.
You are the book.
Okay. Cosine of 105, which sign? Plus or minus?
What's minus, right?
Yeah.
In quadrant 2?
No,
Yes,
wait,
because cosine is F
I don't know.
and X
I don't
is
know.
negative in quadrant two.
There you go. We're in quadrant 2 here somewhere, so we
Yeah, I
understand this is a
think
negative
it's
quadrant.
Yeah, let's go.
What time is it, Max? No.
I was like, ah,
What did you do? My pen like rolled off my desk.
Grant, don't you ever doubt me again.
Understandable.
Cosine is the plus, right? So cosine of 210, awesome. Divide by 2. Let's see if we can finish up before. So always have the little negative in front. That's no fun. Okay, we need cosine of 210 again, please.
1/2.
1/2. Okay, got the other one here. Okay, let's keep on going here. Oh boy. So negative on the outside. Common denominators is 2, so I need a 2/2, which becomes that right there. Is that right? 2/2 plus another 1/2. Negative on the outside of this thing here. So 3/2 divided by 2 makes the square root. Here it is. I'm going to change this guy into a multiplication again. I just want to check something out. Why does it not feel correct?
You did 1/2.
We added
Two
one.
Oh, okay, okay. I was like, what?
Hold on, this does not feel. Just the feeling of it is incorrect here.
Wait, why is it just?
Why is it negative square
It's
root
just
2
gonna
over
come
2?
out to.
The y
this-
value, or
this
the sine
is
value.
210.
Why is this the way?
Oh, you know why?
Why?
I said the wrong number.
Nice.
Can we throw something at
So
Grant?
what is it, Grant?
It's coming out to the cosine value. We did the sine.
Okay, what's the cosine value, Grant?
The cosine value is negative root here.
Gotcha.
Nice.
Okay, let's
Why
start
did
your.
nobody question me?
So it's our fault now.
Absolutely, it's your fault. Mostly yours, bro.
Yeah, definitely.
Okay, let's go with the correct value, negative square root of 3/2.
Grant has reached a level of idiocy that is immoral.
Okay, at this point, you should be able to finish it off because it looks very similar to another one that we just did. So let's guys finish it off. That should be a plus sign. Hate erasing here, but let's go with pin. So anybody see that to be very, very similar to the previous problem?
Yeah.
Cool, okay.
Well,
Can you guys finish
now
it?
I see.
Can you finish it off by yourselves? Bless you. Uh-huh.
But there's a negative on the
There's a
outside.
negative,
Negative on the outside.
otherwise.
Yes.
Again, just letting you guys try it yourself here. See if you finish it off. We are not done with 5.4. So we'll still come back next time on Monday to finish up 5.4. But let's finish off this problem here. Next few minutes here. So. Are we good? Okay. And we're good with just the beginning of 5.4. come back next time and finish it off on Monday. All right, guys, have a good weekend. Once again, don't do anything I would do. And see you guys on Monday.